Okay. So let me confirm this is streaming as expected. All right. So today we'll be talking on the use of Git actions to automatically dockerize. So when we move to Azure for the next phase is when we might do probably a deployment of sorts with probably the Azure App Service or the Azure Container Service or one of them. But without wasting much more of our time, let me just share my screen. Sorry. So I'm going to be sharing my. So I hope you can see my screen.
Yes, I can see your screen.
All right, thank you. So as usual, we'll be starting with a beer repo straight from the grassroots. So let's call this automatic containerization. Okay, so that automatic containerization is public. Is there a readme? Maybe not. Then let's create the repo. So we are going to do something first. We are going to be going to Docker Hub and we will be creating a personal access token because over time most due to the fact that password is a very very sensitive thing. So organizations and guys that work on stuff like this have ensured that okay, I see we have viewers on YouTube. Nice of you guys to join us, and as usual, if you have any question you can just post them on YouTube. I might take some time before I see them, but I'll definitely see them and answer them before the end of the session. So, as I was saying, so organizations they have created a new means of authentication which they call personal access token. So, a personal access token is something that is easier to share around than a password because of for automation and stuff, because for everything we are trying to do we always have to be mindful of security and the fact that there will always be people that will try to like um undermine the security of whatever stuff it is that an organization has online. So we have limited time, so I might not be talking all that much. So this is the Docker Hub um, documentation. So this is just for Docker on how to get a personal access token. So we need this access token, and you will see when we use the access token as the session goes on. So we'll come to Docker Hub. Okay. So I hope I should be logged in already without having to sign up again. Unfortunately not. But my password should be saved, I guess. Exactly. So I knew I should be logged in. So this is Docker Hub. Just as they stated, you can follow. So you select your username bar, select security tab, new access token. So this is my username. So account settings. Then I'm going to go to security, and this is a what an access token. So Docker desktop automatically generates an access token whenever you sign into the Docker Hub with your whenever you sign into the Docker desktop app that I showed to you guys during the last live coding session. So that app automatically creates a personal access token, and that personal access token is what it uses to push your images from your system to Docker. So the personal access token is very important. So doing that, so let's create a new access token. So the access token is going to be for Git action. Okay, you can read, write, and delete, and then let's generate the token. So the token is should the only it says one blah 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 and stuff like that. So apparently my token is visible to the world. Everyone can see my token. So with this token, anyone can try to access my Docker hub, and they should have access to do anything that they want to do with it. So I'm just showcasing it on how to get it by the end of the live coding session, I'm going to deactivate the token. So for safety purpose, I'm going to head over to a page that you guys cannot see currently and just keep it there. Okay, so that's that on that. So as usual, let us get the URL of our page and let me open up a new VS Code and stuff that we are going to be using. So that's like images, personal. All right. So let me just create a new folder and automate container. Okay. So Control V and opening up this with code. So I hope you can see a VS Studio screen now. I hope the screen is visible.
Yes.
All right, thanks. So this is our new our new page, and so let's open up the terminal and clone our repo. So git clone and then paste the URL. So enter. So I'll do this later. So I'm cloning into this, and this I've cloned into this container already. So um, to showcase the difference, I want to just like work on something that is very very simple that we can something that is very very simple that we can probably use to see. I just hope I hope it doesn't take too much of our time because it was something kind of on the spot. So I just want to write a quick web app, and that web app will be dockerized locally. So after dockerizing the web app locally, or should I okay, rather than creating a new one, so as to not waste our time, let me do something. Let me pick up a web app that I've done previously, and we'll just try to make changes to that web app. Think that would be better than starting from the scratch if we actually want to cover and do important things today rather than having to waste so much time. So on the page right now, I'm trying to get the sorry, I'll get this just now. So I think it is this, yes. So let me just I'm trying to see if I have it exactly. So I'm bringing a file now exactly. Control C. No. So we're going to be writing the Docker file from the scratch. So I won't be going too much into the details of this because we are not talking about web app or stuff. What we're actually concerned about is the Dockerization. So this is something that probably might be the focus of something another time, or I can't really say. But I won't be focusing a lot more on that. So let me paste this here, Control V. So exactly. So you can see on the page now that we have new files added to it. So these are the new files that we have added, the templates. So basically, this is just a Flask app. And what this Flask app does is that this Flask app, it opens, if I open index.py, so this Flask app, what it does is it goes into the txt file that we just created, and the txt file contains random codes, different random codes. So it picks up a random code from the txt file and showcases it in this html file here. So this is the html code that showcases the text, whatever text that is. So it renders it using Flask syntax and all. But as I stated previously, I won't be going too much into the details of that. But to get something done, so let me do something really fast. Let me do pip install R requirements. So if this is the first time you're seeing something like this, I don't think it's the first time, but for Python, when you want to do a pip install, you do pip install and the name of whatever module it is that you want to install. But when Python has a way where you can list all of, just like for guys that have been into Node.js or JavaScript, they have something called package or JSON. It's just that's basically what a requirements.txt. But requirements.txt, all you need is the name of the module and the version you want. So if you want the name of the module and the version you want, so all you just have to do is to pick up the name of the module, pick up the version, blah blah blah, and it will install every module for that particular version. So if I press enter now, so could not open, no search file. Okay, I've not changed. I have to cd into the new automatic containerization. I hope I got the spelling right on the first try. Okay, so let me just pick it up. Control C, CD, then paste. All right, so we are here now. Okay, so these are our files. So let me do the pip install requirements.txt now. So you can see Python is immediately installing all of the modules that we are using. So this is something that we do. Is actually, even when you are dockerizing anything, it is always advised that whenever you are dockerizing something, you like pick up, you use, if it's in Python, because in Java, sorry, in Node.js and other web tools, they have package.json, npm, that is able to do all of this stuff. But Python doesn't really have something like that. So in Python, it's always advised that you have a requirement.txt for every thing that you're dockerizing. So immediately you dockerize it, anywhere it is, you can always have access to whatever modules it is that you utilized for that project. So since this is working as usual now, I'm going to run this app. So let me just try Flax run. So I just want to run the Flask app so you guys can see the base image of what we have on that Flask app. Okay. So after doing that, then we are going to then we are going to, so I'm just trying to get the command to run the app. Okay. Let me just try this first. So you can use normal Python index.py. So when you, I see, what's the issue? Index.py. Okay. There's no, so let me just do this now. So if main is equals to name, I hope this is the correct syntax, then app dot run. So what this does is that is what allows Python index.py to work, but that's not the correct syntax. I think this should be name. Exactly. So if I save this now and if I run this, so you can see now that this Python Flask is running. So I'm not going to go into the details of all that, but if I pick up this link, let me control C this. Let me show you guys. So let me just share my entire screen currently. So I think that will be better for everybody. So if I pick up, so if I come here now, so if I pick up, this is the URL that was created for us locally. So if I pick up this, you can see this is it, a simple playground app. So this is the app. So if you click on generate codes, so this is a quote that was created. The greatest pleasure of life is love. If you click on generate codes, but you can see now that there are some times that you click on generate codes and what you're having is, you can see that we are having like empty lines before you bring out another quote. So sometimes an empty line again, another empty line, so another line. So this is working as expected. The Python app is working. Okay, so let me stop this Python app. So to dockerize this Python app now, so inside this folder where we have all of our code, we'll do something called docker file. So this is the docker file. So in the docker file, we are going to specify our base image, and our base image this time is going to be what? Python. And the Python that we want to be using is the Python 3.9. So that's our base image. That's the first thing we're doing. So after picking a base image of Python, so I want to create something called a work die. So the work die part, I'm going to call the work die part. Let me just probably call it code or something. So I'm going to create it here. So it will be created in the what? In the base stuff. So that's the work die code. And then I'm going to copy. So I'm going to copy requirements .txt, and I'm going to copy it into requirements.txt. Okay, that works. So after copying, then I'm now going to run. So run this command pip install no cache. So this no cache command is something that is for Dockerize. I can't really go into specific, but it helps in making sure that your Docker image is not extraordinarily large, because when you create caches, when you create cache that way, you see that your Docker image, because it's trying to keep all of the requirement files that you're installing, so it is unnecessarily large. So we are going to use that command. So requirement.txt. So that's that. So if that has worked as usual, then I'm going to copy everything in this folder. I'm going to copy it into the root folder. After copying everything from this folder, so I believe you guys should like recognize some of these commands already, because they are embedded in your course content a lot. So I'm going to now do something. So this is going to be our CMD, and the CMD is going to be what? Python. Then I'm going to call this what? Index.py. That is the code we use to run it. Okay. So just for our purpose, I'm going to do something called expose. So I want to expose port 5000. What does port mean? You can remember when this stuff started. Yeah, you can see this 5000. So this 5000 is the ports on which this our code is being run. So for every local development, not even local, even online, any development, there's always a port at which you access a website. So it's just like you have a laptop. It is not just, you have to specifically say that this is the avenue for which I want people to be able to what, to access this laptop. So you need to give what, you need to give people access. So basically what you're saying is anywhere that this code is being hosted on, the port at which you'll be able to access the server that is running this code, or the port. So that's a very, very basic description of what we are doing here. So what we are doing here is we're exposing this port 5000, and you see what I mean by exposing this port 5000 very soon. So I'm going to do this, then I'm going to save this as a Docker file. So I'm going to clear my screen. Okay. So now let us use the Docker command. So the Docker command to run, you are going to call the Docker command build dot. So Docker command build. So the Docker build, sorry. So Docker, there's a longer version, but Docker build is the one that people like the most. So we say Docker build. So when you use Docker build and you have a Docker file inside the folder where you are running this command, and you use dots, just to show you what I mean. If I do cd, let me clean this, cd and do dot dot. If I do Docker build dots, it will tell you that there's no, you can see failed to find a Docker file because there's no Docker file in this directory. So if you want to build from a folder where your Docker file is not in, you need to specifically provide an argument where you provide the path to where your Docker file is going to be. But if you know that you're going to be building where your Docker file is located, then you don't have that issue. All you just have to do is to run docker build command and provide that dot. That dot says that look for the Docker file in this directory. So if I run this, it is not what I need. I wanted this route here. Okay, so let me pick this and paste this now. Okay, so now I'm this. So now if I do docker build dots, that's number one. So normally if I run this command will run, but if you do this, what will happen is that your image will get created, but you will not be able to reference your image because you did not give it a name or something. So if you want to be able to access your image, you want to be able to like touch your image after you have built it, or after the image has been built, you have to be able to what, you need to provide a tag command. And what the tag command does is that it names the image. So we are going to provide that with C, and I'm going to call this let me call this, what can I call it? Let me call it quotes generator. Okay, and let me leave it that way. So you must have been, if you have gone through the course content or over time, there's something called tags. So I'll explain what that is in a moment. So probably let me run this first. So we are not going to provide the tag for this. So if I just run this command, if there's no issue with my Docker file, you should see that our command will start running. So you see, so the first thing is that the reason why it's running this fast actually is because you can see that, see all of the installation that was happening locally. So this is now happening in the what? In the Docker container. So in this Docker container, exporting to images name, so it is naming it because we provided a tag. So it has named this to what? To CodeGen. So you can see that this is actually like it's working as expected. And if you go into my Docker desktop here, you can see that I have this image and it was created 4 seconds ago. The reason why it ran this fast actually was because I intentionally ran a Docker file that it brought up this base image. If I had not, if because so it is in my cache, it's not as if my network is that fast. I intentionally did that so in case I add an unstable network, we won't have this issue. So because what Docker does is that when you specify a base image, it downloads everything. So the base image is quite large. Python's base image, I can't get it, but Python's base image is around 196 MB. So it downloads like four layers of base image for Python, and everything is like a total of 500 MB. So if I had not done that process before now, it might still be stuck on waiting for it to finish. But if you go into my Docker desktop, you can see on my Docker desktop, this is the quote gen blah blah blah, and this is basically we running this. Okay, so our Docker image has been created successfully. If I try to go into this image, you see it has layers, and these are the layers: env python get work die code blah 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 cmd python on index, just like I showed you the last time. So this is the what? This is like the image, and this image, no, anywhere you take this image to, and that's the thing about Docker. You don't even, it's not as if you are going to be copying this image of 1 gig. The only thing you need to take is just, you need to take this folder as it is in any, if you place it on a Mac or an Ubuntu system or a Linux distro or whatever distribution it is, as long as it is Docker enabled and there's Docker on that system, all you just have to do is to run Docker build. And immediately you run Docker build, what's going to happen? Immediately you run Docker build, you are going to see that what your code is going to do, what your code is going to automatically run a Docker image on that system that will be exactly the same as this. You might give it another name as the tag, maybe the name will be different, but the content of that Docker image will be the same everywhere. So that's that on creating the image. So how do we now, we have created the image, but how do we now get this image to work where we see a website just as we did previously? So to get that to happen, we have two options. Let me show you the first option using Docker desktop. So if I come here to images and if I click on play, you can see this is the one command. So what this does is it runs a what? It runs a new container, and you can see now that because I specified expose port 5000, you can see that here a port has successfully been exposed. If just to confirm that, if I come to like let me say this code, for example, if I click on one and I expand this, okay, I also exported a port here. I'm trying to get one where I did not export a port to see if I can get something, but I doubt if I have one because it is standard to always ensure. Exactly. Can you see that this one now, no port is exposed in this image? So if you don't have a port exposed, you won't be able to what? There will be no way for you to access the what, wherever that image is on. So as long as whatever it is, that's is mostly for web app. As long as whatever it is you are creating is a web app that you have to access over the internet, you need to expose a port where that image will be accessible, where that you use for accessing the image. So let's go back to our code generator and run this. So let's see, you can see we have a port container name. So you can specify a container name. So I'm going to call this container quote gen cont1. Okay, so this code gen container one, that's all I need since I've assigned a port already, and I'm going to run this. So if I run this, it will take us to this containers part, and you can see that this is running already. Can you see that this is having the same exact line serving flash? If I go back to my command line, and when we created, oh, I've cleared that. But if I just even come here now and do python index.py, but there will be an issue. there'll be an issue because, okay, let me try to do something first. There'll be an issue because the ports, you cannot use two things on your system, cannot use the same port. So since this year is using port 5000, I cannot try to run this again. You see that if I try to run it, to give me an error. Right, this is working. Then there's an issue somewhere because it's not meant to work. Or even if it's working, there will be a conflict. So but basically what I'm just trying to make you guys understand is, you can see that serving flash happening, just debug model, blah blah blah, all of that is happening here also as usual. And if you come here, that's what you have in this container. And if you come to the files of this container, you can see that in the files of this container, you can see, so this is like it's trying to show us like the files of this container. Let us look for something called code. You can see this is the work directory that we created, and in this work directory that we created, see the Docker file. You cannot open it. See the index.py, see the code.txt, see the requirement.txt, see the templates file that we had. So when you create, so whatever part, if you are choosing any other part, you can be able to get your part. If I go into exec, this gives me, and I do ls, or I say print my working directory, you can see that we're in the working directory that is called code. So immediately you specify that work directory, whatever it is that, whatever part it is that you provided, they will be created automatically in your Docker container. Now Docker container is running. So let us see if we can access this now. Can you see that? I don't think we should be able to get this though, but let's try and get something. You can see that this one is closed. So this is not what we're going to be accessing. But there will be an issue. If you come here, let me pick this, and then go to let me go to Chrome. So let me come to Chrome and create a new tab, okay, and do Control V. You see that this site is not connecting. So even though this is running in our Docker container, it's telling us that this is running. If I try to do something like, let me see, can this work? Let me do something like ping. Let me, okay, I think I copied it now in our exec. So let me paste this, paste. Ping not found. Oh, ping was not installed. But if we had a normal Ubuntu, I would have tried to show you that this web server is actually live, but it's not accessible. Why is it not accessible? Because as I stated previously, your container is different from your container is different from your what? Your container is different from your computer. So whatever it is that is running inside your container is not what? It is not running outside your container. So this URL, this 127 blah 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 that is running now, you can see it as it is only visible to anything that is also contained inside the same container. As long as you have moved outside of this container, as long as you have moved outside of this container, then quote one, as long as you have moved outside this container, there is no way for you to what? For you to access this what? For you to access this gen code, because it has to be what? It has to be inside. So you need to do what? You need to give your container a way for it to what? For it to communicate with your host PC before you can then access. So before you can then access whatever is what? Whatever is working on your container. So to do that, I'm going to create the image again. Okay. Or this time, let me do it the other way. So this time now I'm going to do Docker one. Okay. So we are going to specify the image. The image is quotes gen, and you can see something like in the image, this image is given a tag latest. So once we don't provide a tag, Docker automatically names it latest. So latest, I hope this is the right command, because like I don't really use Docker one. And then you should be able to specify the name of the command. So let me say the port. So what I'm doing now is I'm specifying a port that, okay, oh, I know that inside this container there will be a port exposed that is called 5000. So I want you to map, it's called, the word we use is called mapping. So I want you to map port 5000 from my own container to be what? For 5000 on the other container. That might seem a little bit odd here. I'll try, if this work successfully, I'll show you guys what I mean. So 5000 to 5000. Okay, so this has created Docker failed to create tags OCI runtime. We need to start container process Oh, I see. So I think it's not P I should use. I should have used port there. So let me change this to ports and see if this would work as expected. Else I might just exec port not found. Or is it? Okay, coming out. See. I'm very, very perplexed of them forgetting this command. So we could have checked it online, or we could still check it online. Let me see. I think, but we have not even gone to GitHub at all. So I want us, because this is the last live coding session for this stage. So I want us to actually do GitHub and for us to see this thing. So I'm just going to leave that for now. So but what I was trying to do is what I was trying to do is that's using the CLI, but using the Docker desktop. What I'm trying to do is I'm trying to connect this port. So yeah, you see that. So it is called host port. So since there's a port here that is exposed, I want you to connect the host port, which is the port 5000 on my laptop. That's my hard laptop that contains a Windows operating system. I want you to connect that port 5000, connect it to the exposed port 5000 on the container. So let me call this cont quote then cont1. Let me call it cont1 now. Let me run this. So if you run this bind mount inspect blah blah blah, so now you can see that there's a port 5000. So if I now come back here now to this place that was showing me that there was no issue before, if I run this, you see that we should have our, okay, this is not coming. Let me use local hosts. Let me use local hosts. Okay, local host 5000. It's still not coming up. Let me see, but this should work as a GPS. Let me see if I can use this here. Localhost did not send any data. So will I be able to debug this online? Unfortunately not. But the reason why, okay, will not take too much time. So let me go back into this here and let me tell you. I know why this is not working, but I expected it to work because you only have this issue if you have an issue with your Windows subsystem for Linux. So there's something when there's a port mismatch. So if you have a port mismatch, you won't be able to bind the host container to whatever it is. So because of that, so I'm going to go to our Docker file, okay, and I'm going to try. So inside this index.py, I'm going to do something. So I'm going to say hosts is equals to, so our host is going to be 0.0.0.0.0. That's 4 zeros. So if I run this, if I save this now, just to confirm that it is working, Control, let me do Python index.py. Allow access, yes. So you can see that this is running on this. Oh, okay, I think I know why that did not work as expected. But if I copy this, Control C, let me get here, and Control V. So this is working. We have our playground up, yes. Let me do local hosts 5000. So no, this is not what I expected from you. So this local host 5000 still not working. Local host should work. That means I have to fix this later, but we have 127.5000 working already. Okay, thank God for that. So let me do this now. Let me close that. So if you come into this, you see that this is something. See this URL here. If I pick this, Control C, and if I come here, this should also work as expected. We have the same. So let me stop this web app here. Control C. Let me go back into our container. Okay, and let me confirm. So even if I've stopped this web app, I want to see if this will still work. Okay, this still does not work. So since this is still not working, then probably is not what I thought I would. But since we have that's working, so now to rebuild this Docker file, you just have to rebuild it. So now see, you see what I mean by giving a tag. This is 314. So this time I'm going to run docker build, okay, dots. So I'm going to tag it quote then again, quote then, okay, but this time I'm going to tag it version 2. So if I do this, because we just build the previous one, it will not take any time. The only thing it will do is that now that it is going to copy the index.py that it is going to be copying will now have app.1.host in it. So if I come back here now to this, so this is CodeGen container one. You can now see that we have CodeGen. This was the latest. It is still used by that container, but it is still used by that container. And see, this is CodeGen version 2. So it is basically the same image but different tags. And if you check there, we have it. So let me run this now, okay, and I'm still going to now map 5,000 to it. So hey, I did not specify a container name, but oh, okay. So this is not running because there's another one using the same 5,000. So you can see this is what I expected to happen, because once you have the reason why I'm having this error here, if I view details, let me try to run it again and still specify that 5,000. So once you have one port that is being in use already, you cannot use another that same port by another app. You have an error. So see the error. Let's view the details of the error. Okay, so you can see driver field programming connectivity, because the port is already what's allocated. So I'm going to end this now. Okay, so let me stop this container. So I'm going to have to stop this container. So these are the containers that I tried creating, but they did not they did not come up. So let me just delete them. So the reason why they're having these random names are because we did not specify a container name when we were trying to run them. So delete this also. So let me stop this container. I'm going to delete this, and I'm also going to delete this. Okay, so once this container stops, then okay, the container has stopped already. So let me just leave it there and images. So now let me run this and use ports 5. Let me now use the port 5,000. So let me call this count then, or just something. So let me run it. So now we should not have an issue because that port is free. So you can see now that it is running on all of this parallel, and hopefully if I click on this, you can see now that this is working. So the reason why it's what I just did by specifying 0. So you can see now that what, even though I'm accessing this, if I go back to Chrome and use you can see this is working. If I use localhost or even 127 dot something, if I use this, it's also going to work. So what I've done is it's a technical thing of sorts, but over time, if you keep going into this, you learn them. So what I've done is I've exposed that, because on your PC, you can have more than one possible host. You have one host for WSL, you have another host for the PC itself, your local host 127, and you can even have a way to route. That's why your computer itself can act as a server. So what we are using everywhere, servers are actually those computers that have different hosts with different ports available for people. So, but now we have seen that this is working as expected. So what we have done now is we have created these Docker images. We have made it to work. The port is exposed as usual. And one thing I want you to understand is if I come here now and say from this image, let me create another container, optional settings, and I map this time. Let me use something called, let me use 6,000. Even if I use 6,000, let me call it count then 2. Even if I use 6,000, the value will still be the same. So if this container, once this is running, if I come here, you can see that here it is still showing 5,000. Here it is still showing 5,000 because inside the container, we are running it on port 5,000 on different hosts, no problem. But if we come here now and I do 127 and I do 6,000 and I press enter, why is this not working? I should be able to map different tools. Let me come here. I see that's not working. That's shocking because you are not, it is not meant to be a one-for-one mapping. You should be able to map an host from your local PC, any host at all actually, to any another host that is running inside the container. But don't let us waste too much time on that for now. We have our host working. So what I'm going to do now is I'm going to sign into Docker desktop. Okay. So password, yes. So let me sign into Docker desktop. So I want us to, so let me close this. I can close this. So if I go to my, if I go back to my Docker hub now, I think I should see my name here now. Why is my name not showing yet? My name should be showing you already. Okay, proceed to Docker desktop. Open. Let me see. It's still verifying my credentials. Okay, so I'm signed in now. So just before I push to Docker Hub, let's go back to my Chrome. So if I go back to my Docker Hub, so you can see that if I go to my accounts, let me just go to my repositories. You see that I have Udagon, reverse proxy, blah blah blah, Docker Flask image. There's nothing like code gen. So after you have created your image on your local PC, the next thing you want to do is what? You want to move your image from your local PC to Docker Hub. When your image is on Docker Hub, anyone can use it. Anyone can do what? Can use your image. So let me come back to images here. Let me see, just to ensure that we don't have anyone that I've left waiting for a while. I might have left a lot of people waiting. So I just hope, okay, nobody. Let me see, is YouTube still going as expected? Yes, Ayotunde, the video will always be available. We are, all our live coding sessions are always all our live coding sessions are always and they are available on YouTube anytime. So you can just go back there to see it. So going back to what it is that we have here. So for me to, if you try to push, for example, if I try to push this to up, it might work, but there will be an issue. It might work, but there will probably be an issue because you see, requested access is denied. Exactly. So the reason why it's not working is because the way the way Docker Hub works, if you want to push images to Docker Hub, is Docker Hub expects that your image that you're trying to push contains your username in the repository part. For example, if we are going to github.com, you say github.com/oadeniran, that's my username, yes, slash, then whatever repository I want to use. So that's how this one to is. So you have dockerhub.com/oadeniran, which is my username, slash whatever it is. So if you want to move any if you want to move any image to Docker Hub, you have to what? Tag that image having your what? Your username and slash. So if I come here now and do oadeniran slash this and I run this, so this will build another image. Because we are still building the same image, it's not taking any time. The only thing it's going to do is going to what? Rewrite an image. So if I go back to Docker desktop, and you can see now I have oadeniran gen. This is also version 2. It's another image entirely different from this one. And I can now say I want to. So you can use two actions. You can just use here and say push, or you can just come here. If you just do Docker push the image, any of them can work. So I'm just going to come here and say push to hub. So now that I've added my name and what? My name and a forward slash before this, I will now have an error in pushing. You can see that this is pushing successfully to Docker Hub. And once this line that is being loaded, once it gets there successfully, it means our image has successfully been done. What? Has successfully been pushed to Docker Hub. So after pushing to Docker Hub, then this image can be accessible anywhere. And I'll show you what I mean now. So taking a bit of time, but while that is happening, let me just delete all of this. So let me go and stop all the containers that I have. So let me just delete all of these containers. Delete. Let me delete this container. Delete. And let me delete this container. Delete. Okay. So let me come back to my images and start deleting all of these images I don't need. So I'll delete this one. Okay, so that has successfully been pushed to Docker Hub. So quote gen, I'm going to delete every image that we just created just for you guys to see that. So quote gen 2, I'm going to delete. Okay, this one is still Well, it's still uploading. So let me delete this quote gen. So it is still uploading. So I'm just going to leave all of this. I'm just deleting every image. So let me confirm if this image has been pushed to Docker Hub. If it has been pushed to Docker Hub, then I'll delete it also. Let me just confirm if it has been pushed to Docker Hub. So as you can see, it has been pushed to Docker Hub. So if I come here, you see that this is the image. The version is version 2. It's on the Linux Codex. It's an image, blah, blah, blah. And it has been pushed. So I'm going to come here now. And I'm going to delete this image also. So if I delete this image now, it is no more on my system. So it is on hub. As you can see, it is on hub. But on my local PC, this image is not there. So if I do something, I'll come back to this here, and I'm going to do something called Docker pull. Okay, Docker pull, and the image I want to pull is oadenio slash quote then, and the tag is version 2. If I run this, and this runs successfully, so already has blah blah blah. If I go back to my images now, you can see that on my local image, this image is already here. So anywhere, so anybody from anywhere, the other day as you are at home just watching this online, you can just go into your terminal or anything and just say Docker pull, and you will get this image exactly the way it is on my system. It is the exact same thing. There will be no change, and any other person, any number of people can use this particular Docker image, and what will happen? They will use it, and so remember when I was explaining the last live coding session. So that's what Docker does. It gives you a way to containerize everything. So everything, all of the files, the source code, everything has been containerized, and on any system. So someone on Mac will want this same code using Docker to work exactly the same way. Someone using Linux, someone using Ubuntu, someone using Windows servers, any OS at all can work with this image that I just created and pushed to Docker Hub. So that's the first stage. It took a lot of time, but this is actually what we should have done last week. But due to the fact that I had issues with network, that's why I was not able to do it. So that is that on that. Um, I'm just now going to breeze through the GitHub stuff. So we have created that. So now we are sure our code is working. I can clear this. Let me reduce the size of this. So we are sure our code is working as expected. The image is building. We have everything there. Okay. So now we now have to work on our action file. So as usual, our action file is going to be in .github, and it will have something workflows. Okay, and so under this folder, we're now going to create the ci.yaml. So this is the ci.yaml GitHub. Okay, so let me do that. So as usual, and I remember this offhand, I say the CI. Okay, so this is the CI. This is the CI file. Okay, and then do I remember all of these syntax? I actually don't think I've ever written a syntax file off the top of my head. So I'm going to, so after the name, let me just try and get one from all of the ones that we wrote the last time. So let me, personal, git action demo, dot github, workflows, workflow one. Let me just open this with Visual Studio Code, so can just like exactly. So that's the name. Then the on keyword. So the on keyword is going to be workflow dispatch, as workflow dispatch as usual. Okay. So I'm going to leave workflow dispatch. Then I'm going to say every time you push, and the branches that you're going to activate anytime you push is going to be a what? Is going to be the main branch. Okay, so that's on. This is what makes my code work. So on, then now I'm now going to specify the jobs. So the first job is going to be using. So it is always advised that for every action you're writing, as long as it's an action for a production or something, you use checkouts. You use the checkout action. Okay, I'm not good. So this is checkout. So what the checkout action does, do we have it somewhere here? Okay, we don't have it somewhere here. Let me just go online and pick up the syntax for the checkout action. What, as I stated the last stage when we were talking, so this is the action that checks out for a repo. So what it does is it creates a new folder in whatever. So let me just pick it. Yeah, so it uses action start checkout at version 4. So let's go back here, and this is our CI. So it's always advised that you use this so that you always have your sequence was not expected. Let me confirm that I'm using. Okay. So it's always expected that you always have this action. Oh, sorry, I've not defined the steps. Steps. Okay, so now that I've defined the steps, then this should be what's indented under here. Okay. So the first, you always expected that you should do a what? A checkout sequence token. Okay, it's always expected that you should do this here. Okay, so it's always expected that you should do this. So use this action checkout for, then we are going to call the next step. Okay, so the next step we have something called name. Okay, and the name of this step is going to be login to Docker. Okay, so this one is also going to be using. So this one is also going to be using. So let us go to let us go to Docker. Exactly. So I decided, so this is the Docker login action. So any action you want to use, the best way, okay, just to like show you how I got this. So let me just come here and say git action login to Docker hub. You see, GitHub action to login, blah blah blah. So you can see once you search for whatever it is, as long as there's an action that has been created for it, you see it in the marketplace. But you should also be careful that you're not just using action from anybody. At least you try to use action that is verified. The action is either from GitHub or it's from the organization that owns that tool that you're trying to use. So if you're trying to use something from AWS, try to ensure that the action you're using was also created by by AWS. But this is the login action, and what you just have to do is you authenticate. You can see they said it's when authenticating to Docker or with GitHub action, use a personal access token instead, and all of those stuff. So you can see they have even also provided a template for how you can use it. So what we're just going to be doing is we'll be picking this part of the name. So this is just we need. Okay. So it uses this action with, okay, I'm still having an issue here. Why am I having an issue? Should not have. Oh, okay, I've seen the issue. So this should be steps, not steps. So these steps. Okay. So that's number one. Then the mapping token was expected. Oh, let me see. Oh, I see. So this is jobs. Then I'm going to call this the name of the job one. So the name of the first job, for example, if you go into this file, you can see that after we specify jobs, we then specify the jobs name and the OS that this is going to be running on. Okay, so I'm going to call this will be the login to Docker job, or let me just call this push, let me just call this containerized job. Okay, so and the containerized job is going to have these steps, and these steps are exactly so. At least I think we have our stuff now. Oh, sorry. Okay, so use this. Why am I having? Okay, just trying to ensure that our syntax is correct. Exactly. So I'm meant to containerize job. It runs on, and it's going to run on Ubuntu latest. Okay. So I'm going to say, so you need to provide an input. I remember, if you remember the last our live coding session, then also I also showed us how we can create reusable, workflows, where I created one in another folder and I used it in another in another place. So you need to be able to create a reusable workflow. So what we are basically doing here is, if you go, you can see this is the workflow file that we're using, this action.yaml. If you open this action.yaml, you will see that it is basically an action file, and see inputs blah blah blah, one is using node blah blah blah. So they just wrote this action, but it is nothing different than what we did throughout the last stage, where we are writing different actions ourselves. So we are going to be using the password. So okay, exactly. Okay, not exactly Docker Hub. So I'm going to I want to log into Docker Hub. So we are going to be using the we need the username input. Control C, username input, and we also need the password inputs. But as they said, so you can now see the reason why I created a personal access token from the beginning. So the personal access token is what we are now going to use to the personal access token is now what we are going to be using in this instance. And as because it should not be shown, so as you can see here, when you are working and you are working with something that uses a secret, we call them secrets. Secret are things that should not be exposed to be public, things like passwords, things like personal access tokens, environmental variables, and all. You are not meant to write them at all where they can be visible. You're always meant to provide them as as secrets to your GitHub repository. So because we are actually almost short on time, I wanted to skip it before, but it is what it is. What's what doing is what doing well. So we'll come to settings. Okay, and then so this is how to set a secret for a repository. So we have come to settings. Okay, in these settings, we are going to come to this. So this is security deploy key. So this is secret and variables. So we want to specify secrets for actions. So these are the secrets, environment secrets. So we are going to create a new repository secret. So the secret name, let us call it Docker Hub. Most time when you are creating secrets, the idea is you want to use all capital letter. So Docker Hub PAT. Okay, so now remember I said I kept this somewhere, so I'm going to pick this up now, Control C, and I'm going to paste this here, and I'm going to add the secret. So immediately you add the secret, you cannot see it again. That secret, that's what it will be. Docker GitHub will have access to it. GitHub can see it, but GitHub will never show it out, because it's it's a secret. So let's just follow their convention to the end. I think in their action also, they also put the name as a secret. So let us go back to our page and let us add another secret. Let's call that Docker. So let me user. Okay, so my username is Oadeniran, or let me just confirm, but it should be Oadeniran. Exactly. So this is our username here. So this is my username. So my username is Oadeniran, and I'm going to add these secrets. So now that I've added this secret, so I just need to use the what? The secret context. Remember then when we used inputs to access the value of the input, what did we use? We used input dots. But when you add something called secret, you use what? Secret dots. If you use environment variable, you use m dots. So they are called context, and that's how you work with Git actions. So these are things that we spoke about in the last stage. So I'm going to come here now. Okay. So I'm going to access our secret with secrets dot I called it docker underscore hub underscore user. Okay, so I'll just copy this also. So we're using our password token, and I'm going to call this secrets.docker.pat. Okay, so this is the first. So what this step does is that these steps log into Docker. So immediately we are done logging into Docker, what's the next thing we need to do? We need to what? Containerize. We now need to containerize the app. Okay, so we are going to containerize the app. We are going to need another what? Another action. So we're going to need another action which we'll be using in containerizing, and this action, okay, I missed this exactly. So it's going to be using what? Uses. Okay, so let us go again as usual. Let's go back to Git exactly. So let us say build image from Docker file Git action. So you see, you can see that Linus blah blah blah, creating a Docker container action, marketplace blah blah blah, GitHub. So even GitHub docs, even Docker docs also, they have official documentation for how you can use a what? How you can use a GitHub action to what? To work with container Docker. So let us see introduction in this guide, then blah 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 blah. Action metadata file. Exactly. So this is what we need. We just need to now what? We use this for our own use case. So we can say these are the inputs, running Docker inputs, integrate. So writing the action code, blah 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 blah, GitHub output, entry, creating a readme. Is this what I need? Exactly. Get output time. Let me see. Upload artifact, GitHub workspace. So I don't think this is what I need. Actually, creating a Docker container action. So this is the Docker file. Okay, exactly. One's using. Oh, I see. So there's actually a step where you can just run this. Wow. But this is not what I need. So let me just go back. Let me just go back. Exactly. So you can see you can build and publish images with Docker. Create. Okay, go dig. I don't want something. I saw something yesterday. Let me check the GitHub Actions itself. So create repository, exactly, the personal access token, Ubuntu latest. So this is the one we just use, logging in. Exactly. So this is what we need. So as I stated, there's nothing, as long as you're able to understand what it is that you want to do, you see that all of these things, documentation is your friend for almost anything you want to use. GitHub, Docker, Terraform, Chef, Ansible, serverless, just name it. Anything it is you want to use, there's a documentation for almost any use case. All you just have to do is understand how you can what? Understand how you can use this, how you can do what? How you can like ensure that you can use those documentation for your use case. So based on this, I have what I need already. So all I just have to do now is set up Docker build. Okay, Control C. So basically we need to so I'm going to call this name. So call this setup Docker build. So what this does is it gives your Ubuntu that is running, it gives your Ubuntu that is running the something, because you are running, as I said, as you said earlier, we are running this on Ubuntu latest. So what it does is that it gives it the ability to what? Run Docker commands. If you don't want this step that is called setup Docker build, you won't be able to what, when you start using the Docker build and stuff, your Ubuntu that you're using to run your action will not have the ability or the capacity for it to do what? For it to be able to get that action itself. So you need to be able to run set up Docker build. Understand? So you can read more about that later. So it's going to be using what? As usual. So now let's go back to our documentation that we're following. Okay, so now we're going to be I'm just going to lift all of this, not typing, because to spend some time here. So I'll just paste this here and then pick what I need. Okay, so I think I can start from here. So then I can take all of this a step back. Shift tab. Okay. Then I just say width. Exactly. So you can see, so this is a Docker build push action. So what this does is you provide a Docker file, it will build with that Docker file, and what will it do? Based on that Docker file, it's just going to what? It's just going to based on the Docker file, it is just going to build that image and push it to your hub. And remember that when we're trying to work locally also, you could not push to hub unless you named it what, you had your username in front of it first. So I'm going to replace this because it not use username. You will use secret.docker hub user, and we're going to replace it with quote gen. Okay, and this time we're going to be putting it with latest. All right, so that's containerize the app, containerize and push the app. So if this worked as expected, if it runs successfully without any issue, you can see that on my Docker hub here, the quote gen I have is just v2. If it runs as expected, we should be expecting to see another what, image. Let me ensure that I use the same name exactly, quote gen, and this one will have a tag that is called what? That is called latest. So I'll save this. Okay, so now I'll now use git. So git add git commit am first push. Okay, then git push Yoko. Sorry, I thought I was deploying. So let's just do git push. So this should push to our as usual exactly. So now let us go to our Docker, to our image here. So now let us see if our action is up. So you can see our first push is running already. So as you can see, so this is the first issue. So logging into Docker container has failed. Username and password required. So it is saying username. Okay, I see. So I did not provide password. I think it should be an issue with my spelling. I did provide password. So was, oh, I see. So probably for this is not an issue with spelling. When you see that, when you go to your action and you can see that you are trying to use an environment variable, you are trying to use a secret, you are trying to use an input or something, and you are sure that there's no issue with your spelling here, then the issue is probably with what we are calling. If you can remember correctly, I did not specify that secret as Docker PAT. I specified it as both Docker or PAT. So if I save this now, so I'm just going to do a git add. Okay, I'm going to do a git commit, and the commit message is going to be that fixed secret typo. Now I'm going to push this now. Git push. Okay, so now let us go back and let us see the new one that is running action. So we have a new one that is running and containerized job. So let us follow it as it's going along. So you can see logging into Docker, we have logged into Docker successfully. So we have already set up the Docker builder and our Docker builder is working. And you can see that our Docker app is already containerizing automatically. You can see extracting blah blah blah. So these are our Docker hub. So this is our image. You can see this is the second part of the code. Work directory is equals to code. This is it installing all of our what requirements in the txt. So it has renamed. Our action has run successfully. Copy. I want to see where it actually tagged the image. Let me see. So pushing manifest quotes then latest. Exactly. So now let us go into my Docker hub. Here is my Docker hub, and let us refresh this page. We should see that there will now be what latest. Can you see? Latest is already here. It has an image. It was pushed a few seconds ago. This and that. With this now, we already have a GitHub action that anytime you make a push to this container, anytime you make a push to this GitHub repository, you don't have to now start typing Docker build. You don't have to start doing Docker run. Immediately, your code is what built, containerized, and deployed. So we've actually spent some time, but I'll try to make sure that we end by 4 p.m. sharp. So that's basically everything. So to just showcase an instance of the fact that we are automatically building and deploying, you can see. So no, we're automatically building. That's why I named it just CI. I did not name it CD, because in DevOps, when you are doing CI/CD, so CI is the part of integrating a new code. That's continuous integration. So when there's a new code, it gets integrated into the previous database. When there are changes, it gets integrated both automatically and continuously. So when you move from integration to deploying, that's when you add the second line, the second key, which is the deploy. That's the CD aspect. So now, just for demo purposes, what can we do? Exactly. You can remember that the previous time when we were getting codes, or just to show that, let me do python index.py. Okay. So if we go to our image, we are done with the action, so I can close all of this. So let me close all of this. Let me close all of this. Let me close all of this. So I need just this. So let me do this. You can see that there are sometimes when we click on generate quotes, we have empty images. So the reason we're having empty quotes is because if you go into this quotes.txt, you can see that there's an extra line everywhere. There's an extra line. So we are doing a random selection. So it's possible that when you do a random selection, your random selection will select this empty line and just print it and return it as the what? As the random text. So let us try to include a piece of code. Okay. And white text is equals to. So let's try to include a piece of code that will ensure that our random that will ensure that whatever it is that we pick, if it is a new line, it will not be returned. We only return a quote when we are sure that it is not a new line. So I'm going to use this. I think this is what we use to specify a new line. Okay. So that's just what I have to change here. So what I have to change is, if so I'm initializing text. I don't have to explain all of this, but what I've just done is that while the text that is being returned is a new line, what's going to happen? I'm going to ensure that we keep getting another text until we get a text that is not a new line. So let me save this. The bulb is not on, so I have to stop this and then run it again. So if I go back into this web app now, and now start clicking on gen, you see that every time I click generate codes, I'm not going to ever, why did you have to do like this? I should not have a new line. So let me see what is happening apart from the fact that there's a new line. Okay. So this is 20. So, okay. So while is not equals to, okay, or let me add something. Text is equals to, or another way, the easiest way, this is a hack you get. So I know that the only way, based on the data that I have, the only way it can be a text is if it was, at least if the length of that line is more than 3. Okay. So what I'll just do is, while text is equals to new line, or the length of text is what? Less than 3. Okay. Give me a new stuff. So let me save this. Let me cancel this, and then let me just do this. I just want to get this off our plate first. So now if we load this up, so when we generate quotes every time, so when we generate our quotes every time, so you can see now that there's no point in time that I will ever get, even if let me just keep this. So let me just keep refreshing using F5. So you can see that there's no point in time that we're ever going to get a what? An empty line. Cool. So now let us do this. All right. So we have done that successfully. Now let us end this, Control C. And now let's do a git add. Then we're just going to git commit. Okay. And our message is going to be what? Fixed empty quotes. Okay. And now let me push this. Git push. So if I push this and our code, so if we go back to our GitHub page here, where we are running our secrets, and we look at what, let's try to, okay, go up. Let's see our action and the CI file. You can see that this is running. So if this is running as expected and we are containerizing, so it is setting up, we have logged into Docker successfully. It is setting up the container build. But the only issue with this one now is that on this page, it does not have cache. You understand? So it is always going to keep doing it, but that's not an issue because you don't care about that one. Yours is to just work on a containerization that will work successfully, and it should take it to what? Put it on Docker Hub. So Docker Hub is not the only Docker registry repository. There are other places that you can keep Docker images. Even GitHub itself has its own, they call them container registries. GitHub has a container registry, Azure has a container registry, Amazon, most dedicated cloud providers, even Heroku, a deployment platform that is not a cloud provider, you can see our containerized job has been done. If we go into our Docker Hub here and I refresh this page, you see that the last time it was pushed will change from 2 minutes ago to just now, or just a few seconds ago or something. So you can see that the last time it was pushed was what? Just a few seconds ago. So our code was immediately what? Pushed to GitHub. It was immediately containerized and it was immediately what? Pushed to GitHub. So for the last thing for today, is we're now going to be running both code to see that there's a difference. Okay. So I'm going to come here to this page. I'm now going to use Docker pull. But this time, what am I going to be pulling? I'm going to be pulling oadenion / quote gen, but this time I'm pulling latest locally. So once I pull this, you can see it is pulling this. So but you can see that there was a change somewhere. So because of that change that was there somewhere, it has tried this. But this has what run successfully, and you can see that we. All right, so you can see that our Docker hub, what it has put this image. So if I go into my Docker desktop, you see that now I have both quote gen latest and quote gen v2 on my container. So also see that the image that was pushed without working on it locally has been done. Let us run both containers. Let us run the v2 first. So if I run this v2 container, okay, let me specify 5,000 as usual. I'm not specifying a container name, I just want to run something. So since I specified this container name, so let's just wait for this to come up. You can see, so this has come on. So let us open a page up for this. So you can see we are still having an empty quote. So let me just keep using F5. Sorry. So you can see that we're having, okay, I need to click on generate code first, sorry. So as you can see here, we're still having, okay, so F5. So you can see that was an empty quote. This is an empty quote again. This is an empty quote. This is empty. We are still getting empty quotes. We are still getting empty quotes. This is what the V2 version that we use. So let us stop this version. Let us stop it. And let's delete it. And now let us go into our images. Okay. And now let us run the latest version that we just pulled. Play. As usual, it's going to be 5,000. And let us run this. So since I've run this, sharp and stand blah blah blah. So let us use this link to go there. And you can see if I click on generate codes, you will see that no matter how much no matter how much I load this, we are never ever going to get a what? We're never ever going to get an empty code. So today we have successfully seen how we can do what? We've successfully seen how we can integrate um, GitHub Action and Docker to what? For a continuous integration where our code is automatically sent what? To GitHub, Dockerized and put to Docker Hub also. So with that, literally I've said a lot actually. Is there any question that probably something that you need like to be shared upon? Let me stop sharing my screen.
I think at this point, I would actually have to like go over the video entirely because indeed you said a lot. So I need to like go over the video entirely.
I understand, but it's a very simple process and it's an hands-on video. So when you are trying to go through the video the next time, just try to have your Docker and stuff installed and just try to go through it step by step. It's a very simple thing and that's just the way it is. So with this, you can extend not only for Docker, but other things. But as long as you are able to get the syntax, how it flows, and you see that it will come to you easily. But as usual, while going through it, if you have any question or need explanation on any concepts, you can just drop the question on the DevOps group and I'll be happy to oblige you.
Thank you.
Yeah, you're welcome. So with that, that's the end of today's live coding session. Yeah, the only one that came for this live coding session, and that's okay. I think we have someone on YouTube also. I'll try to see if I can figure them out. I might probably have to like probably do give like a sort of penalty for every other person that did not come because it's not compulsory here, but at least people should try to show up when you try to make a commitment. All right, do have a wonderful rest of the day and bye bye for now.
Thank you very much.